Hello everyone and welcome to this video on solutions to linear equation, and we are going to be looking at the concept of the Newton-Raphson iteration method, and this is going to be involving one variable. Alright, so before we start to look into it, if you are new to the channel PA Academy or you are yet to subscribe, kindly go ahead right now, click on that subscribe button to subscribe to the channel, and do make sure you also give the video a thumbs up and also click on the bell icon so that you can get notified of any of our subsequent videos. Alright, so thank you very much if you have just done that. So now let's get into the video proper. We are looking at Newton-Raphson iteration involving one variable. There are also Newton-Raphson iteration that also involves two independent variables. We have three variables. Okay, so that will be coming up in subsequent videos. Alright, so that's the more reason why you need to also subscribe to the channel. So go ahead and do that right now if you are yet to subscribe to the channel. Alright, so now for us to apply Newton-Raphson in solving question involving one variable, here is the formula that applies to that you can see on your screen right now. So you can see right here we have s of square n plus 1 is equals to x of n minus f of x and then f prime of x. Okay, so we are going to be using an example to illustrate this concept. Now if you look at the example 1 that we have on our screen right now, it says use the Newton-Raphson method to find a solution of nonlinear equation. So this is equation right here. X sine x equals to minus 4, starting from x naught equals to 4. All right, so how do we go ahead to apply this formula that we are having here for us to solve the question? All right, so let's get started. All right, so first now let's write out the equation. That means our f of x is equals to x sine x a plus 4. All right, so what I've just done is if you look at it, that this is what we have here, but we can also have it as x sine x. If this 4 minus 4 should come to the other side of the equals to sign, it becomes plus 4. Okay, so it becomes plus 4, and that is what we are having here. Okay, so don't let that confuse you. Okay, so if you are to look for the f prime of x, okay, so that is, you just differentiate the f of x. So and in differentiating x sine x plus 4, that's going to give us s cos x plus sine x, and then if you differentiate it as 1, then if you differentiate the x, that's 1, then plus 0. Okay, so if you differentiate 4, that will give us 0. Okay, with that we are going to be having s cos x plus sine x. All right, so now that we already have the value for we already have our f of x, and we also have our f prime of x, which is this right here. We can go ahead and bring in the formula, all right, which is what we are seeing right here. Okay, so with that we are going to be having n plus 1 equals to xn minus, all right, so the xn you are seeing is this particular xn. Okay, then this f of x, and this is it right here. All right, so you're going to be having minus, so instead of this x is what I'm representing with xn, sine xn plus 4 over, all right, so let's go back to the formula again. So f prime of x of n. All right, so with that, and this is our own f prime right here, so I'm going to be having xn cos xn plus sine xn. All right, so I hope it's making sense like that. If you're finding value in the video, please give the video a thumbs up. So now we are going to start with the first iteration. So for first iteration, all right, now remember that they already told us that x naught is 0. Okay, you can see starting from x naught is that's x of 0 is equals to 4. So we are starting with 0. So what that means is that our n, okay, is 0. All right, so if you should for the first iteration where we have our, let me just write that our x naught is equals to 0. So that means this is our n here. All right, and if I should put it into this, okay, that will be x1, because that will be 0, so that means here is 0 0.1 0 plus 1, which is 1, so equals to, so this n is already 0, so that will be x naught minus x naught sine x naught plus 4 over x up to 0. I'm just saying like that because x subscript 0 plus sine x subscript 0. All right, and okay, sorry, this our x naught is 4 here. It's 4, not, it should be 4, not 0. So now we're going to substitute that 4 into this. So that means our x1 will be equals to, so our x naught is 4, and it's given in the question anyway. So you see it right here in the question. We're told that I'm starting from, you can see x naught is equals to 0. Okay, I mean it's equals to 4 rather. All right, so that will be equals to 4, then minus, so let me put this into a square bracket. All right, because the minus is for everything inside the square bracket. So that will be 4, so our x naught is 4 sine 4 plus 4 over 4 cos 4 plus sine 4. All right, now if you should do this correctly, now you have to also take note that if you are using calculator to calculate this, ensure that your calculator is in radian, not degree. Okay, so let me write it here so that you can always remember. So ensure your calculator, it does, if you are using your calculator, ensure your calculator is set to degree, I mean radian rather. Not degree. Okay, so degree on calculator is DEG. All right, so if you do that from your calculator, you are going to be getting your x1 to be equals to 4 minus, so what is going to be there is minus 0.2885. all right, so but if you're not set to radian, you're getting something different, so you need to set it to radian. So that means our x1 will be equals to 4 plus 0.2885, and that's going to give us 4.289. all right, now this is not where we are going to stop. We are going to do another iteration, and I'm going to let you know where we are going to stop now, because we've gotten a value for our x1. So let me just write it out. Now 4.289. so what we are going to do is we are going to do a second iteration, and I will let you know when you are to stop. So I'll go ahead and say for second iteration, so our second iteration will be x2, so which will now be equals to x1 minus x1 sine x1 plus 4 over x1 cos x1 plus sine x1. all right, so just similar to what we did in you can see, just similar to what we did right here. Okay, so but now we are doing our second iteration, so it will be x2, and if you look at the initial formula for this, we have it to be, you know, n plus 1. okay, and then the next one is always, all right, so let's just continue. All right, so in doing this now, we can we can see that we have a value for our x1, which is 4.289. so that will be 4.289 minus, okay, so let's put this in square bracket, so that will be 4.289 sine 4.289 plus 4 over 4.289 cos 4.289 plus sine 4.289. all right, now if you should solve this, don't forget, make sure your calculator is set to radian. all right, so we are going to be getting our x2 to be equals to 4.323. now when are you supposed to know where you are supposed to stop? Because for this now we are still going to continue to our third iteration, and let me tell you why. So let me just write it out. As for third iteration, now the question might tell you where to stop, but in most cases they might not tell you. So where you will stop is when you are getting your current x value, maybe x2 or x3, is the same thing with the subsequent x value. So that means maybe if you are getting your x2 value, and when you get your x2 during your second iteration, the value you are getting, maybe you are getting 1, and then when you did your x3, you're also getting 1, then you know that you're supposed to stop. That's your value for x that you're actually looking for. Okay, or that's the solution of the equation. all right, but once you are not in that point where your current x value and then your next x value is the same answer, you just have to continue. Okay, so that's why you can see now our x1 is giving us 4.28. you can see it here, 4.289, and this is giving us 4.323. All right, you can see that they are not the same thing, so that means we need to continue. All right, so now for our third iteration, it's still the same step. So that will be x3 is equals to x2 minus x2 sine x2 plus 4 over x2 cot x plus sine x. Okay, so if you put in the values, now we already have our x2, so this is the x2 value that we are going to make use of in calculating our x3. So our x2 is 4.323 minus, okay, 4.323 sine 4.323 plus 4 over 4.323 cos 4.323 plus sine 4.323. Okay, again, if you calculate this correctly, you're going to get in your x3 to be equals to 4.323. All right, now what do you notice? Just like I was explaining earlier, you see that our x2, which is 4 points, there's a point here, there's a decimal point, 323 is the same thing with our x3, and that means we can then conclude that hence x is equals to 4.323 is a solution. Okay, so that's how you know when to stop. All right, so this is the first example we are going to be looking under this Newton-Raphson iteration involving one variable. In the next part of this video, we are going to be looking at another example, which is a totally different example, just to give you more understanding on how to make use of the Newton-Raphson iteration involving one variable. So I hope you find value in the video. If you have any question or any doubts, do let me know in the comment section. And if you still don't understand any part of this video, I will encourage you to watch the video again. Take your time to understand all of the steps. You might need to write it out again so that you can have proper understanding. So thank you very much, guys. My name is Prosper, and I'll see you all in the example 2 of this video. Bye for now.